Okay, everybody, and welcome to Chapter 3, Graphing Quadratic Functions. Now, as you can see on this page, there are a lot of standards that we're going to cover in this chapter, but first of all, we're going to start with section 3.1, and in 3.1, the standards that we're really going to focus on are these three that kind of lie right there. So I can graph quadratic functions and show key features of the graph. So before we actually start really delving into graphing quadratic functions, we're going to look at this idea of key features. So we've got intercepts, maximums, minimums, increasing, decreasing, positive, negative, domain, and range. So we're going to try to figure out all that stuff about our quadratic function, and then we'll really start looking at all those other standards. So 3.1 is characteristics of quadratic functions, and we're first going to start with the definition of a quadratic function. So a quadratic function is a non-linear function that can be written as f of x equals ax squared plus bx plus c. Okay, now in that, this is called standard form. And really, this should take you back to chapter 2 when we were doing our polynomials. So for example, we could have f of x equals negative 3x squared plus 4x plus 1. So that is a quadratic trinomial because the degree up here is 2, quadratic, and then 3 terms. 1, 2, 3. And this is written in standard form. So specifically for this chapter, when we're graphing quadratic functions, we're going to be graphing things that kind of look like this. And we're going to write them in different forms and do different things with them, but that's pretty much what we're going to be looking at. Now, a parabola is the shape of the quadratic graph. Okay, and on our next slide, we're going to look specifically at what that parabola looks like. But if we use the word parabola, we're just talking about the shape that the graph makes. Kind of like a linear graph makes a line, a quadratic graph makes a parabola. So let's take a look at what we call our parent function. So f of x equals x squared is just our basic graph before we do anything to it. Okay, so x squared, we've got a quadratic graph. Now, in order to figure out the rest of our table of values over here, we're going to take our x values and we're going to substitute them in to our parent graph. Remember, when you're substituting, you always want to use parentheses. So we've got x squared, and x is negative 2, so we're going to have negative 2 squared, which is 4. So if I'm going to plot that point, I'm going to have negative 2 comma 4. So I would go negative 2, 1, 2, 3, 4, and that would be a point on the graph. If we keep going, negative 1 squared is 1. So that point would be negative 1, 1, negative 1, 1. 0 squared is 0. So 0, 0. Substituting in 1 squared is 1, so 1, 1. And then substituting in 2 squared is 4, so 2, 4. And you can kind of see the shape of our function take place. And if you're looking at it, it kind of looks like a U. Okay, now do not confuse this with your absolute value function. An absolute value function is a V. It has a straight line on the left and a straight line on the right. This is not a V, so if I see you graphing a V, I'm going to mark it wrong. Okay, these are not straight lines. It's actually pretty curved at the bottom. So when you come down here, you're going to curve and kind of go up and curve and kind of go up. Okay, it doesn't have to be completely 100% curved, but this should not be coming down like that. It should not be a V. Okay, and then this graph right here that we just graphed, this is your quadratic function, and it's called a parabola. Okay, now the first two key features that we're going to look at on this page are the domain and the range. And on the next page, we will actually formally define these things, but try to remember what domain is. And if you do remember domain, domain is all your x values. Okay, so all the x values of the graph. And the way I find that is I have my handy dandy green little highlighter here, and I kind of highlight my x values. So I start in the middle. Okay, and I'm going to go to the left, and I'm looking and I'm going, okay, does my graph exist, or does my graph have an x value? So at -1, yeah, it's touching. If I go -2, yeah, it's touching. If I go in between, yeah, it's touching. So this is all part of my domain. Now the question becomes is, well, what about out here? Am I touching? And I can't see it, but yes, I am, because this graph has an arrow on the end, so it's going to keep going forever. So eventually, if this keeps going off the page, it will touch. It's just going to be out here. Okay, so you have to picture your graph, and I know this isn't actually happening. It's just a huge exaggeration that your graph is like just going to keep going that direction. So yes, your domain keeps going forever in that direction. It just keeps going. Okay, so domain, if we keep going the whole way to the left, we're going to start with, and I'm going to write this in two different ways. We're going to have interval notation, and then we're going to have inequality notation. And you're going to be responsible for both, although I'm pretty sure your book uses this one. Okay, but most math teachers use this one, which is why I'm going to make you responsible for both. So interval notation, we're starting at -infinity. We're going the whole way out to the left. Then we're going to come back here to 0, and we're going to do the same thing to the right. So touching, 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 going to positive, 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 touching. Are we still touching out here? Same idea. You can't see it, but yeah, it's going to keep going. If I were to exaggerate once again, it would just keep going forever, 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 forever. So that would mean it goes out to positive infinity. Now we have this conversation of brackets versus parentheses. Brackets mean touching, parentheses mean getting really, really close to. You can't actually ever touch infinity, so we're just going to put parentheses on both sides of that, and that's interval notation. Okay, now inequality notation here, that would be y or x is greater than, x is less than, something like that. But because we have -infinity to infinity, we're just going to write this fancy looking r, which means all real numbers. Okay, so your domain is all real numbers. It goes the whole way left to -infinity, the whole way right to positive infinity. Now we're going to take a look at our range. So our range, and again, we will formally define this, is all your y values. Once again, we're going to write it in interval notation, and we're also going to write it in inequality notation. So all your y values, well, your y values go low and your y values go high. So I'm going to start kind of here in the middle, and we're going to start with low. Is there any part of the graph that is down here at -5, -4, -3, -2? And the answer to that is no. Okay, this graph doesn't have an arrow that points down here. There's nothing down here. I'm not highlighting anything. So then the question becomes, well, when do I actually start touching the graph? And it would be right there. Okay, that's when you actually hit that graph, and that is at 0. So interval notation, we're going to start at 0. And then we're going to say, okay, well, that's how low the graph goes. Well, how high does the graph go? Is there something at 1? Yeah, I'm hitting the graph twice. What about at 2? What about at 3? What about at 4? Yep, hitting the graph, hitting the graph, hitting the graph, hitting the graph. What if I go up here? So technically, yeah, I'm not hitting it, but remember that conversation we had about these arrows? They're going to keep going. They're going to go forever. They're just going to keep growing, growing, growing the whole way up to infinity. So my y values, and I apologize, that's a really bad infinity. But my y values go the whole way from 0 down here to infinity, the whole way up at the top. Now, brackets versus parentheses. We already talked about infinity. You can't touch infinity, so that's going to have a parenthesis. But what about 0? Are we actually touching? Is there a physical point at 0 that the graph is touching? Yes. So we're going to put a bracket. Now, inequality notation. Keep in mind for domain, you're talking about x's. So it's x is greater than, x is less than, etc. When you're talking about range, we're talking about y values. So y is greater than, y is less than, etc. And your y values start at 0 and they go bigger. So inequality notation, we're going to have y is greater than 0, but more importantly, y is greater than or equal to 0, which is why we have this bracket over here, because we're actually touching this point right there on 0. So that is your parent function. The blue graph is called a parabola. That is your domain. That is your range.